In this video, I'm going to find the derivative of inverse trigonometric functions. I'm going to teach the inverse trigonometric functions. Here we have the arcsin x, arcsin fx. As you see, it's similar to each other. Only the derivative of arcsin fx, f derivative x over 1 minus fx squared. Like x derivative is equal to 1 minus x squared. If we compare with the cosine, arccosine and arcsine, only the difference is minus sign here. And for the arctangent, 1 over 1 plus x squared. So this is going to be f derivative x over 1 plus fx squared here, as you see. The effect for the fx, which is different than x. F derivative x over fx squared plus 1 it should be. And as I told you before, between arcsine and arccosine difference only minus sign. Between arctangent and arccotangent, again it's going to be minus sign. Here the formulas are same, only we have minus sign here. And the first question is find the derivative of arcsine x squared. Arcsine x squared derivative is equal to, here the fx is equal to x squared, so f derivative x over, the formula is here, f derivative x, which means x squared derivative over square root of 1 minus fx squared, which is equal to x squared it must be, and then it's equal to 2x over square root of 1 minus x squared minus power of power, multiplication of power, 2 times 2 is equal to 4 is going to be. Okay, the second function is arccotangent e to the power of 3x. If you remember the formula, fx, the arccotangent fx derivative was equal to f derivative x over minus, of course, the difference between tangent and cotangent, I said, 1 plus f square x it should be, which is equal to minus, here the fx value is e to the power of 3x, e to the power of 3x derivative over 1 plus e to the power of 3x square is going to be. Then e to the power of x derivative, it is simple, the minus sign we shouldn't forget. E to the power of fx derivative is equal to, if you remember, e to the power of fx times f derivative x it should be. So f derivative x it should be, which is e to the power of 3x times 3x derivative is going to be here. This is the derivative over 1 plus e to the power of 3x times 2, which is equal to e to the power of 6x it's going to be. And the last one here I'm going to write e to the power of minus e to the power of 3x times 3 over 1 plus e to the power of 6x is going to be the answer. Okay, here we have two different functions, one polynomial function which is x squared and e to the power of x. So f derivative x, when we say x squared minus arccosine e to the power of x derivative it's going to be. And here, if you remember, the important part, instead of x squared derivative is arccosine derivative. Arccosine e to the power of x derivative it's going to be. And x squared derivative is going to be equal to 2x minus arccosine derivative with minus sign. If you remember, with the sign which was plus, it was with plus. Arccosine it's going to be with minus. So here it's going to be equal to arc e to the power of x derivative, fx derivative, arccosine fx derivative is equal to fx derivative over minus 1 over 1 plus fx square. It's going to be, here it was minus, minus fx squared, it's going to be, so it's equal to square root of, but here we have one more minus also, square root of 1 minus 1 minus e to the power of x squared is going to be, then it's equal to 2x plus e to the power of x derivative, it's equal to e to the power of x over 1 minus e to the power of 2x is going to be. This is the end of the question. Okay, sorry. We are going to find the equation of the tangent line here. Equation of the tangent line, when we say I need two variables, one of them is m, the other one point, because I need to find the y minus y1. Y minus y1, this is equal to m times x minus x1, the equation of tangent line with point and slope form. I'm choosing point and slope form because by using the derivative I can find the slope. That's why I'm choosing this way. Okay, then the fx here, the inverse trigonometric function. So for finding the slope, I need to find the derivative of this expression. So y derivative is equal to f derivative x, which is equal to 2 times arc cosine x over 2 derivative. This coefficient, it's not going to be important for us, and 2 it's going to written again, and minus the f derivative x over, if you remember, f derivative x over 1 over square root of 1 minus x fx squared it's going to be. So fx is here x over 2 derivative over square root of 1 minus x over 2 square it's going to be, then square it's going to be, then it's going to be equal to minus 2 times x over 2 derivative is equal to 1 over 2, because x derivative is equal to 1 it's going to be, so the result it's going to be 1 over 2, then over here over square root of 1 minus x squared over 4 is going to be the answer. And if you simplify this to f derivative x is going to be equal to minus 1 over square root of 1 minus x squared over 4 is going to be, then f derivative x, when I say here it gives me the slope also, m is equal to f derivative root of 3 it should be, then this is equal to minus 1 over here minus 1 over square root of 1 minus square root of 3 square over 4 it should be, that's equal to minus 1 over square root of 1 minus 3 over 4, which is equal to minus 1 over 4. It's going to be 4 times 1 minus 3, so minus 1 over root 1 over 4 it's going to be root 1 over 4. I should write a bit up this one. That's equal to minus 1 over root 1 over 4. Root 1 over 4 is equal to 1 over 2 minus 1 over 1 over 2. That's equal to minus 2. So m is going to be equal to minus 2. I found that m is equal to minus 2. And m is equal to, here, the m value is equal to minus 2. I found this one. What about the point? Point means, as I repeat here, but at the beginning, y is equal to fx is equal to 2 times arc cosine x over 2. And I know the x value. If I know the x value, I can find the y value, because I need x1 and y1. If I give the x1 here, if I replace the x1 here, which is this value, I can find the y1 and I replace that values in the function. So y1 is equal to 2 times arc cosine x1 over 2 it's going to be, y1 is equal to, this is x1 also, x1 2 times arc cosine root 3 over 2 it must be. Arc cosine root 3 over 2 it's equal to what? We should find that one. Arc cosine root 3 over 2, if I say it's equal to alpha, then here cosine alpha it should be equal to root 3 over 2, and we know that cosine 30 is equal to root 3 over 2, so alpha is equal to alpha is equal to 30 it must be. But if you write the form in degree form, it will mix the question. That's why we had to write in radian form, because if it is, let's say, pi over 6, pi is 3.14, at the end you will find one y value on the x-axis, but y is number here. When you use 3.14, the result will be number here. If you use the degree, the result will be degree. That's why we cannot find exactly on the y-axis. We should find the y value. I'm going to skip to this step. Y is equal to, y1 is equal to 2 times pi over 6, which is equal to 2 pi over 6. When we simplify that one, it's going to be equal to pi over 3, and this value is approximately 1.14 over 3. It's going to be 3.14 over 3, sorry, it's going to be, and 3.14 over 3 approximately 1.03, it's going to be 1.03 approximately it's going to be. Okay, then the x value is equal to root 3, and y value is equal to pi over 3 it's going to be, and y minus y1 is equal to m times x minus x1. When I say for the equation of the line, and here y minus y is general value, y1 we found it's equal to x1 and y1, I didn't write them, x1 and y1 x pi over 3 it should be here, and m is equal to minus 2, x is general value again, and x1 is equal to root 3 it's going to be, and 3 the answer is going to be like this: y is equal to minus 2x and plus 2 root 3 and plus pi over 3 is the answer, the equation of the line, and this is approximately we can find approximately one value for this number, and 2x minus c, it's going to be minus 2x plus c is going to be